A couple is pair of equal and opposite forces that are acting on the body, but they are not having the same line of action. So when such forces are there, or the characteristics of couple, first is that the two forces must be equal in magnitude, they should be in opposite in direction, and they should have separate line of actions, that is non-collinear and parallel, and the couple is going to produce pure rotation. The couple will be producing pure rotation and it does not produce any translation. So here one force, let us say if it is F, the other force will also be F, and the distance separated between them is D. So couple will be about the midpoint. If we consider, then it is F into D by 2 plus F into D by 2. It produces clockwise movement. Here both F1 and F2 are producing clockwise movement about the midpoint. So F into D will be the couple that has been exerted on this point. So when we are trying to open a tap, or when we are trying to unbolt or remove the nut out of some assembly, then the couple is being exerted. Next is ideal effort. The ideal effort is the minimum effort that is required to be applied to an ideal machine which is having 100% efficiency and there is no friction. So ideal effort is the minimum effort that needs to be applied to an ideal machine, and ideal load is the maximum load that can be lifted by a machine, or basically an ideal machine whose efficiency is 100% and no friction is present. Velocity ratio is indicated by VR. So this is expressed as displacement of velocity ratio is expressed with VR, that is, it is distance moved by effort divided by distance moved by load. Simple formula, and velocity and mechanical advantage are equal for an ideal machine. State Lami's theorem. If the body is in equilibrium under the action of three concurrent coplanar forces, the each force is proportional to sine of the angle between them. So if there are three coplanar and concurrent forces, then the sine of the angle subtended between, if there are three coplanar and concurrent forces, then each force is proportional to sine of the angle that is subtended between the other two forces. So F1, then the angle alpha should be marked between F2 and F3, and for F2 the angle has to be marked between F1 and F3, and for F3 the angle has to be marked between F1 and F2. Let's call it as gamma. So the formula becomes F1 by sine alpha equal to F2 by sine beta is equal to F3 by sine gamma. So the forces should be away or converging, or the force should be diverting away from this point O, or else the forces should be meeting at the same point. They should be converging. So let's say if this is F2, and if the direction of F2 is reversed, if this is F2, and let's say if I reverse the direction of F2, same way the direction of F1 also has to be reversed, and it should be placed like this, and F3 also, the direction of F3 also has to be reversed. So either the forces should be directed towards the point, or they should be directed away from the point. Only then we can apply Lami's theorem. If any one of the force is drawn in a different way, but the other two forces are directed towards the point, then in that case we cannot apply Lami's theorem. Or else at least we should be able to form a closed polygon by using these forces. So let's say if I begin with F1, so this is F1, I have kept the F1, and on the head of F1 I will place it F2. So this will be F2 force, and F3 will be placed on the head of F2, and it will be directed towards the tail of F1. This is F3 and this is the tail of F1. So this way the closed polygon or closed triangle will be obtained. So now here if we mark the angles, that is, this was F1, this will be F2, and this would be F3. So the angle subtended between F2 and F3 will be 180 minus of alpha, or else this angle here it would be alpha, and the angle between the extension of F1 and F2 is gamma, and the angle between the extension of F3 and F1 is beta. So this angle is 180 minus alpha, this will be 180 minus gamma, and this would be 180 minus beta. So F1 should be taken by the angle which is on the opposite side, that is 180 minus alpha. F2 should be taken by the angle which is on the opposite side, that is 180 minus beta, and F3 should be taken up with ratio as in the angle on opposite side, that is 180 minus gamma. So even if you try to apply the same, you will be getting the answer as F1 by sine of 180 minus alpha is once again sine alpha, F2 by sine of 180 minus beta, which is once again sine beta, and F3 by sine of 180 minus gamma, which is sine gamma. So this is a Lami's theorem, very important whenever we are dealing with three coplanar concurrent forces. Next we have perpendicular axis theorem. So perpendicular axis theorem, it is for the plane lamina, a flat 2D body, the moment of inertia about the axis perpendicular to the plane. Moment of inertia about the axis perpendicular to the plane is the sum of moment of inertia about two mutually perpendicular axes that are lying in the plane and intersect at the same point. So IZZ is summation of IXX plus IYY. So here if the rectangle is given to us, this is x-axis and this is y-axis. Moment of inertia about z-axis, the axis which is perpendicular to the plane, is summation of moment of inertia about the x and y axis which are lying in the plane. Next is mechanical advantage. Mechanical advantage is expressed as ratio of load lifted by the machine to the effort applied. So mechanical advantage is load by effort. So if mechanical advantage is greater than 1, then the force is multiplied, and if the mechanical advantage is equal to 1, then the force is, if the mechanical advantage is equal to 1, then the force direction is changed, and if the mechanical advantage is less than 1, then it is not the force multiplication, it is the speed multiplication that happens in the bicycle. This is resulting speed multiplication. Body of weight 200 newtons is held vertically by means of two strings which makes an angle of 30 degrees and 60 degrees with horizontal. Find the tension in the string. So let me just draw the diagram. Let's say the string is T1 and let's say this is T2, and there is a weight of W that is equal to 200 newtons. Now if we observe here, it is consisting of three coplanar concurrent forces. So all is that you have to apply Lami's theorem over here. So the angle included between T1 and W is 150, and this is 120 degrees and the remaining angle is 90 degrees. So W by sine 90 is equal to T1 by sine 120 equal to T2 by sine 150 it is. So T2 will be equal to 200 by sine 90 is 1 and sine 150 is 1 by 2. This is 100 newtons. And T1 is equal to, that is 200 into sine 120 is root 3 by 2, which is 100 root 3. Two forces of magnitude 30 newtons and 40 newtons are acting on a body. The angle between them is 20 degrees. Find the magnitude and the direction of resultant. So here we can make use of parallelogram law of vectors. That is, let's say force P is equal to 30 newtons and Q is equal to 40 newtons and angle between them is 20 degrees. Magnitude of resultant is R is equal to root over P square plus Q square plus 2PQ into cosine of theta. That is root over 30 square plus 40 square plus 2 times of 30 into 40 into cosine of the angle between them. So this comes out as equal to 52.206 newtons, and the angle between the resultant and 40 newton force can be computed, or else 30 newton force if we consider. That is, for computing the direction of resultant, the angle or the expression is given by tan theta is equal to q sine theta divided by p plus q cos theta it is. So q is 40 into sine 20 divided by p is 30 plus q is 40 cos 20. So here the angle would be equal to 11.45 degrees. So here we have taken the reference as 30 Newton. 30 Newton was taken as horizontal and 40 Newton was kept at an angle of 20 degrees. And now that the resultant has been estimated, so resultant will be closer to 40 Newton, and that is 52.206. The angle included between 30 Newton and 52 is 11.45, and the angle between the resultant and 40 Newton force will be 20 minus of 11.45, which is 8.55. So remember that the resultant will have more closeness to the force which is higher in magnitude. And if we want to write the resultant in the form of vectors, so here it can be expressed. The unit vector here, the 52.206 is making an angle of 11.45 with the x-axis. So the unit vector would be I cos 11.45 plus j sine of 11.45. This would be unit vector r cap, which is specifying the direction, and the vector can be written as 52.206 cos 11.45 I cap plus 52.206 sine of 11.45 j cap. So either of the ways it can be followed. So sometimes they also expect us to express in the vector form. So this is also required to be learned. What is self-locking? And mention the condition for self-locking. Self-locking is a condition in which machine component such as a screw jack or power screw does not move in the reverse direction under the application of load until and unless the external force is applied. In the simple words, the load, if it is trying to move backwards on its own, the motion of the load is going to be restricted by using the friction force. So for self-locking to happen, the angle of friction, that is phi, should be greater than the angle of repose. For the self-locking to happen, the angle of friction should be greater than the helix angle. Alpha is the helix angle and phi is the angle of friction. So if we are using the friction force in order to lock or in order to prevent the motion of the load in the backward direction or the downward direction, then the efficiency is going to be affected. That is, efficiency will be less than or equal to 50%. A bullet of mass 0.1 kg is fired into the target with a velocity of 350 meter per second. Mass of the target is 10 kg and it is free to move. Find the loss in kinetic energy. So here in the question, we can make use of the concept called conservation of momentum. So mass of the bullet is 0.1 kg, velocity is 350 meter per second, and mass of the target is 10 kg. So let me write this as initial velocity, as we are required to know the loss in kinetic energy. So initially the target mass of 10 kg is at rest, that is u2 is 0. So here we can apply the formula, that is m into u1 plus capital M into u2. This is equal to m into v1 plus capital M into v2. So initially this is at the rest. So this will be striked off, and mass is 0.1 into 350 kg, and this is, here it is getting embedded inside the 10 kg mass. So both will be having common velocity, that is final velocity will be small m plus capital M into Vf. That is Vf is equal to, this is 0.1 kg. So 0.1 into 350 divided by 10 plus 0.1 it is. So upon calculation, this is equal to 3.465 meter per second. Next is, we need to calculate the loss in kinetic energy. So that is delta or Ke loss is equal to initial kinetic energy minus final kinetic energy. So initial will be half into m into u1 square minus half into small m plus capital M into Vf square it is. So this would be 0.1, that is half into 0.1 into u1 is 350 square minus half into 10 plus 0.1 into Vf is 3.465 square. So this upon calculation will be equal to 6064.34 joules. Define the lower pair and the higher pair and give the examples for each of the following case. So lower pair is a kinematic pair which has surface contact between the two connected links, and they have relative motion that is completely constrained. So relative motion which is completely constrained means there is only one motion in the one direction, that is degree of freedom is equal to 1. So shaft rotating in the bearing, it is going to form a turning pair or rotary pair, and slider moving in the guide or cylinder is going to form sliding pair, that is straight line motion or linear displacement, and this is telling you about angular displacement. So shaft rotating in the bearing is an example of turning pair or revolute joint or revolute pair, that is the output variable what we get is theta, and slider moving in the guide is the linear displacement of the body, which is given by, let's say, x, nut and bolt is going to form a helical pair, which is also an example of lower pair. So linear advancement of nut, that is equal to rotation given to it. So still this is having 1 degree of freedom only, as degree of freedom is telling us about the independent coordinates. Okay, spherical joint, ball and socket joint, this is having 3 degree of freedom, but this will be called as lower pair only. Next is higher pair, is a kinematic pair in which the contacting elements have point or line contact and the relative motion is partially constrained. So cam and follower, we are finding a point contact. Gear is an example of higher pair. Ball bearing, roller bearing is an example between the ball and roller, the type of contact that is been established. Okay, that is higher pair. And wheel rolling on the surface is also an example of higher pair. So here when it says partially constrained means degree of freedom could be either greater than or equal to 1. Differentiate between the structure and the machine. To begin with, the structure is going to support the loads and withstand the external forces without the moment. So here without moment means no relative motion between the connected members. No relative motion between connected members. Whereas machine is used for transmitting and transforming the energy into some useful work. Motion of parts, no relative motion between the parts, and the parts have the relative motion with respect to each other. So due to this, the wear and tear is less, and here the wear and tear is more on the basis of this point. Next is no conversion of energy takes place, and conversion of energy into mechanical work is the specialty of the machine. Examples are, for the structure, the examples are bridges, buildings, dams, frames, towers. All these are examples of these structures. Engine, pumps, cranes, turbines, lathe, milling machine, human body, all these are examples of machine. The members in the structure are subjected to tensile and compressive forces, whereas the nature of force in the machine is cyclic forces, friction forces, and dynamic loads. Impulsive loads also is also the part of it. Next is components and links connected to maintain the shape and not for the motion. No relative motion, and here also same is being reflected. Next is the machine is going to consist of kinematic links, pairs that allow control movement. This control movement is telling us more about normal working of machine. Next is effect of wear and tear is very low or it is static in nature, whereas for machine it is high wear and tear due to the presence of friction. So main objective of the structure is to maintain the stability and strength, whereas the performance of machine is judged on the basis of efficiency, productivity, mechanical output, and the quality of work that is being produced. Write the differences between the machine and a mechanism. So machine is a device which is converting the energy into useful work, and whereas the mechanism is associated with transforming and transmitting the motion without producing the work. And the primary purpose of the machine is to perform the task. It could be lifting, cutting, pressing, punching, etc. These are the operations, and the primary purpose of the mechanism is to control the motion or force within the system. Machine is going to consist of one or two or more number of mechanisms, whereas mechanism is going to be a soul or working model behind a machine. Okay, so if we try to draw an analogy, a human body is going to consist of various systems, that is nervous system, cardiac system, pulmonary system, digestive system. So all these systems together, they can have the analogy with respect to mechanism, and human body, which is consisting of all these systems, can be treated as a machine. List out the three inversions of a 4-bar chain. So 4-bar chain has three inversion. The first inversion is crank mechanism. So this is based on the range of motion of link. That is, first one is crank mechanism. So input and output links both will be completing circular motion. One is to indicate the motion of input and another is to indicate the motion of output link. The second inversion is crank rocker mechanism. So input link or the crank is a link which completes circular motion and rocker is a link that completes oscillatory motion. So rocker is associated with oscillatory motion and crank is associated with circular motion. And the last inversion, that is rocker mechanism. So both the links, that is input and output links, will be completing oscillatory motion. So the inversion number 3 is rocker mechanism. So but here sometimes the other books also point out that the inversion 4 as rocker crank mechanism, but this is still similar to the inversion number 2. So in general, there will be 3 inversions only, as fourth inversion is not bringing any distinctness in the working. Next is link. Link is a rigid body, or it should be a resistant body. Instead of rigid, it should be a resistant body, and it should be connected with other members for the purpose of transmitting relative motion or force. It is, instead of motion, I should write it as relative motion, because connected bodies are involved, so then the motion is replaced with the relative motion. Link may be a single piece or an assembly of pieces together that is going to form a one rigid body. Understand that link could be a single body itself, or it could be combination of the bodies. Those bodies are assembled, or you could say bolted, welded, or riveted. If you say, still it is the same thing, because these kinds of joint will be used to form a single body. Next is kinematic pair is the combination of two links that are in contact and permit relative motion between them. The type of kinematic pair is decided by the relative motion, that could be sliding, turning and rolling. Write the law of machine with effort versus load diagram. So the law of machine is expressed by the relationship between the load and the effort that is being applied. So effort P is equal to M times of W, which is load, plus C it is. So P here it is referred as effort, M is the slope, and W is the load, and C is the additional force that is required to overcome the friction. Let me just show you the load versus effort diagram. So let's say this is X and Y axis, and on this the variation, the load and effort relationship is a straight line. So it's a straight line, but here there is an intercept present, that is C is the Y intercept. So instead the load line would be starting from here. This height is C, and this will be load versus effort diagram. In the question, it says about the velocity ratio of a machine is 10, that is VR is equal to 10, and effort applied is E is equal to 150. Load to be lifted is determined, that is W is to be calculated if 20% of the effort is lost in friction. So useful effort, that is equal to percentage of effort that is lost is 20%. So we have only 80% of effort, it is 80% of E it is. So that is 0.8 times of 150, which is 15 eighths 120. So this is 115 to zero point 0.8 is 120 newtons. Next is load is equal to useful effort, useful effort into velocity ratio, that is 120 into 10, which is 1200 newtons. The question is about a simple machine whose velocity ratio is 30. Load of 2400 is lifted by an effort of 150 newtons. And in the second case, load of 3000 is lifted by an effort of 180. So load in the first case is given as 2400 and the effort is 150 newtons. And in the second case, the load is increased to 3000 newtons and effort is 180 newtons. Now the law of machine is required to be calculated, and the load when the effort is 200 is required to be estimated. So W or P is equal to M times of W plus C. So here in the first case it is 150 equal to M into 2400 plus C. Next is in the second case effort is 180 equal to M into 3000 plus C it is. So now if we take the differences, this is minus 30, this is minus 600 M plus C. So M is equal to 30 by 600, which is 1 by 20. So the value of C needs to be calculated. So 150 is equal to 1 by 20 into 2400 plus C. So C will be 150 minus 20 ones are, this is 120s. This will be 150 minus 120, which is equal to 30. So now the law of machine will be, that is P equal to 1 by 20 times of W plus 30 it is. So next is we need to calculate the load when the effort is 200. So if P is equal to 200, the value of W needs to be estimated. So this is 200 equal to 1 by 20 times of W plus 30. So this is, if we subtract, this will be 170 equal to 1 by 20 times of W. So W is equal to 170 into 20, which is 3400 newtons of load can be lifted. The larger and smaller diameters of a differential axial are 80 and 70 mm respectively. The effort applied to the handle at the end of the lever is 120 mm long. What is the velocity ratio? And find the efficiency and frictional effort lost when the load lifted is 8000 newtons and effort applied is 320 newtons. The smaller diameter, that is small d1, that is 80 mm, and d2 is equal to 70 mm, and the diameter of larger wheel, that is d, is equal to 2 times of length of the lever, that is 2 into 120 it is, that is equal to 240. Velocity ratio for the differential axial, it is given by 2 capital D by D1 minus D2, which is 240 divided by 80 minus 70, which is 24, is the velocity ratio. 2 into 240 divided by 80 minus 70, which is 48, is the velocity ratio. Next is efficiency we need to determine, and the frictional effort lost is also to be determined. Mechanical advantage is given by load by effort, that is 8,000 divided by 320. So 0 and 0 will be cancelled. This is 8 fours 32 and this is 8 hundreds, and this is 4 ones and 4 25s. Mechanical advantage is 25, and efficiency is given by neta is equal to mechanical advantage divided by velocity ratio, that is 25 by 48. So this will be slightly greater than 50, that is 50.08%. Next is the effort lost in friction. So here we can make use of the formula, that is effort lost in friction, PF is equal to, that is applied effort minus load by velocity ratio. So this is P applied effort is 320 minus load is 8,000 divided by velocity ratio is 48. So this is 8 648 and this is 8 thousands, and 1000 by 6 is approximately equal to 150 or 160, 153.33. So 320 minus 153 will be, so this is 48, 8,000 by 48, that is 8 thousands by 8 6, and this is 2 500s and this is 2 3s 6. So 500 by 3 is 167.33 approximately, 167 or 163. So if we subtract that from 320, this will be 153.33 newtons is the effort lost in friction. Effort lost in friction. The question says about a differential wheel and axle. The difference between the axle diameters is 100 and the question says about differential wheel and axle. The difference between axial diameters is 50 mm and the diameter of effort wheel is 750 mm. So difference in diameters, let's say that is delta D, which is D1 minus D2, that is equal to 50 mm, and the diameter of wheel, that is the bigger one, is 750. If the load is 2500 is to be lifted by an effort of 175 newtons and a load of 3250 is lifted by 210 newtons, determine the law of machine. That is, first case, the load of 25 newton is being applied with an effort, that is P is equal to 175. Same way, the load is increased to 3250 and the effort is increased to 210. So what is the law of machine? That is to be determined. And if the load, what is the magnitude of load that would be lifted if a effort of 225 newtons is imposed? And the bit C says about mechanical advantage, and the bit D is about velocity ratio, and E is about the efficiency. So let's begin the computation of first parameter, that is law of machine. So here the standard straight line equation we remember, that is P is equal to M times of W plus C it will be. So P is 175, M is not known, and W is 2500 plus C. Second case, P is 210 and W is 3250 plus C it would be. So now if we subtract these two equations, that is C will get cancelled, and this is 210 minus 75 is 35 minus 35. This is equal to minus, this would be 750 times of M. So M is equal to, that is 35 by 750 it is. So this will be 5 sevens 35, and this is 5 150s is 150 fives or 15 fives are 75 it is. And this is 7 by 150 would be the slope, that is 7 by 150. Now in the bit 2 it is asking the effort is 225. In that case, what is the load that is to be lifted? So first is that we need to calculate the value of C. So first, that is 210 is equal to 35 by 750 into 3250 plus C it is. So 0 and 0 will be cancelled, and this is 5 sevens 35, and this is 5 15s, and this would be 15 ones, 15 twos 30, this is 15 into 20. So 15 into 21 will be 315, and this will be 21 point change would be the value. So let me just check. 21.66 into 7 is, C will be equal to 210 minus 151.66. So this is equal to 58.33. That is the value of C. Next is bit B, that is if the effort is 225, that is P is 225, then W is equal to how much? Now the values of M and C are known. So 225 is equal to M times M is 7 by 150. W is to be calculated, and this is 58.33. So W upon calculation, that is, this would be 3571.43 newtons of load can be lifted. As you are increasing the effort to 210, load has been increased to 3250. Same way, if the effort is increased by 15 units, the load also will be increased, but the equation will be, that is P is equal to 7 by 150 times of W plus 58.33 it is. Next is bit C is about computing the mechanical advantage. So mechanical advantage is expressed as load by effort. Mechanical advantage is load by effort, and here in the problem we would be considering the maximum load that has been lifted. On that basis, the mechanical advantage is predicted. that is 3571.43 divided by the effort is 225. So this is equal to 15.87 newtons. Sorry, it's a dimensionless quantity, and mechanical advantage is predicted on the basis of operating conditions, predicted or calculated based on operating conditions. Next is, after the mechanical advantage, we have is velocity ratio and efficiency. So velocity ratio, that is VR, which is equal to 2 times of capital D by delta D. So 2 times of capital D is 750 divided by delta D is 50. So 50 ones, and this is 50 tens is 500, and this is 50 15s is 750. So velocity ratio is equal to 30. Next is efficiency. Efficiency is equal to mechanical advantage divided by velocity ratio, that is 15.87 divided by 30. So in that case, the efficiency will be less than or slightly greater than 50%. 0.529, or which is 52.9% is the efficiency. Explain the crank slider mechanism with a neat sketch. So let me just draw the crank slider mechanism. First is that it will be consisting of a smallest link which is completing circular motion. This will be the fixed link to which it is pivoted, and this is the locus of a point on crank when it is in circular motion. And to this crank, connecting rod is attached. This is link number 1, link number 2, this is link number 3, and the other end of the connecting rod is having piston attached. Piston is link number 4. So as the crank undergoes circular motion, the piston is going to reciprocate to and fro. Okay, so 2 is the crank, and this is also L minimum. This is also L minimum, that is shortest link or the smallest link. Link 3 is connecting rod, and link 4 is piston. Link 1 is the frame. So this is used in the IC engine, and here you find circular motion. Circular motion is converted into straight line motion or reciprocating motion. So you could add more number of points, but the diagram and its appearance is a lot has got a lot more importance. And if you understand the diagram and its working, the other points can also be compiled simultaneously. Explain the Whitworth quick return mechanism with a neat sketch. So first is that Whitworth mechanism is an inversion of crank slider mechanism. And here the Whitworth mechanism is analogous to working of double crank mechanism. Let's try to understand the sketch. So here this would be the shortest link, which is L minimum. Now I will add another link adjacent to it, which is having more length than L minimum. This is fixed link. There will be another link that is slotted bar. Let me just draw the slotted bar. The slotted bar would be like this. This would be the slotted bar. And on this side, there is a piston. The piston is going to move along the slotted bar. This would be the line of stroke of the piston. Now, to the other end of the slotted bar, there is a additional link that is being attached, and to this link there will be a cutting tool that will be connected. So now the line of stroke of cutting tool will be passing through the center of rotation. This would be center of rotation. So if you try to understand the working of Whitworth mechanism, here there will be six link mechanism actually it is. So first is that the link 1 is fixed, this is link 2, this would be link 3, and slotted bar is link 4, this is link 5, and cutting tool is link 6, and this is once again link number 1. So locus of link number 2 is going to be a circle. So this will be locus of link number 2, and the center is this point. So this will be the center of the circle. Let's call it as O1, and this would be O2, and the link 4 will also be completing circular motion. So let me highlight it with a different color so that the two circles are presented from the different centers, and this is the radius. So this is the working of Whitworth mechanism. So how you place the link 5, either if the piston, that is link number 3, if it is placed on the downside, no problem at all. The uniqueness in the Whitworth is that link number 2 is going to be a crank which completes circular motion, and link number 4 is also going to be a crank which is completing circular motion. So here in the mechanism, you find 5 revolute joints and 2 prismatic joints. So if we count, this will be revolute R1, this will be revolute R2. Between 3 and 4, there is a prismatic joint, as there is a sliding motion between 3 and 4. So this will be P1, this will be R3 revolute, this will be revolute R4, this will be R5, and this will be P2. So 5 revolute and 2 prismatic joints. So link 2 is in circular motion and link 4 is in circular motion, and link 6 is going to have straight line motion. And quick return ratio formula is given by, that is, cutting angle divided by return angle. So kindly go through the sketch thoroughly and understand the working. So it is the L minimum that has been fixed, and because of that we are finding the link to completing circular motion and link 4 also completing circular motion. But the radius of rotation of both the circles are different. The center of rotations of both the circles are different. Illustrate the working of crank slotted lever mechanism. In the crank slotted lever mechanism, instead of fixing the L minimum, the fixed link will be adjacent to L minimum. So basically you are fixing the crank, I can say, as per the crank slider mechanism. So next is adjacent to this, I will add a smallest link, that is L minimum, and to this link a piston is attached. Now let me just draw the slotted bar. There will be a piston, that is link 3. Let me add it. And let me just number the links. So this is fixed link, link number 1, link 2 is crank, link 3 is piston, link 4 is the slotted bar, and link 5 will be added on the top of the link 4. Let's say this is link 5, and it is connected by the means of revolute joint. This will be the cutting tool, and cutting tool is once again placed on the link number 1. This is link 5. So here, that is, it is a inversion of crank slider mechanism. Link 1 is fixed, that is frame. Link 2 is crank. Link 3 is a piston, but link 4 is rocker. You can also say slotted bar, because link 4 will not be completing the circular motion. Instead it would be having arc of a circle. So for link 2 it's going to be a circle, but for link 4 it is not the circle. This crank slotted lever mechanism is used in the shaper machine. Okay, locus of link 4 will be an arc like this. It is going to only oscillate to and fro, but link 2 will complete circular motion. And the link 6 is going to execute straight line motion. So remember here, that is link 2 is L minimum, or it is shortest. Link 1 is adjacent to L minimum, and link 1 is also referred as connecting rod as per crank slider chain. So you can add up the points and you can elaborate the working. So try to draw the sketches of these mechanisms, because it helps you a lot, and the students are prone to get confused, especially with Whitworth mechanism and crank slotted lever mechanism. In the Whitworth mechanism, you are finding the two circles with two different centers, and the circles has got two different radii. Next is, in the crank slotted lever mechanism, the locus of input link, that is link 2, it is circle, and the locus of output link, that is link number 4, it is an arc of the circle. So this is analogous to a crank rocker mechanism, whereas in Whitworth mechanism you are finding the two circles of for link 2 and link 4. So Whitworth is crank mechanism. If this session made engineering mechanics easier for you, like, comment your doubts, share it with your friends, subscribe for more high quality engineering tutorials every week. Your support helps the channel grow and reach